Section 8, solving linear and rational equations. Now, given an equation, its solution is a value that makes the equation true. For example, the equation 2x minus 1 equals 13. It's true when you set x equals 7. The left side is twice 7 minus 1 is 14 minus 1 is 13 equals the right side, and it works. You can check solutions by substitution. That's what this was. X equals 7 is in fact checked as a solution this way. But how do you find solutions? That's the question. For linear equations, what we use are equation rules, also known as transposition. Here's the idea. If you have two equal quantities, then you can add the same thing to both sides, and it's still an equation. You can subtract from both sides, still an equation, multiply by the same number of both sides, divide by the same number on both sides, take negatives on both sides, and take reciprocals on both sides, and they will remain an equation. Equal operations on both sides of an equation yields an equation. Now, if you use that plus a cancellation, you get transposition. The idea is for here, if x plus a equals b, then we subtract a from both sides, cancel, and get x equals b minus a. So if x plus a equals b, you subtract a from both sides and get x equals b minus a. If x minus a is b, then you add a to both sides, x equals b plus a. If x times a equals b, we divide by a on both sides and get x equals b minus a if a is not 0. If a is 0, then we have problems. There may be no solutions, and there may be many solutions. If x over a equals b, we multiply by both sides by a and get x equals ba. If minus x equals b, we take the opposite of both sides, x equals minus b. If 1 over x equals b, then reciprocals give you x equals 1 over b. So in this case, x and b are opposites of each other. In this case, x and b are reciprocals of each other. This is called transposition because it's as if this letter a changed side from one side of the equation to the other. And that way leaves x alone, which is what you want. All right, and the idea is we use these rules to solve for a variable. For example, if 2x equals 34, then divide both sides by 2 and get x equals 34 over 2, or x equals 17. If x plus 2 equals 34, we subtract 2 from both sides. You get x equals 4 minus 2, which is 32. If x over 2 equals 34, we multiply both sides by 2. X is 34 times 2, so x is 68. If x minus 2 equals 34, then we add 2 to both sides and get x equals 36. Here we're going to have to do several transpositions to get x by itself. First, we add 5 to both sides. So 2x plus 3 over 4 equals 6 plus 5, that's 11. When we multiply both sides by 4, get 2x plus 3 is 11 times 4, which is 44. Then we subtract 3 from both sides and get 2x equals 44 minus 3, that's 41. Then you divide both sides by 2 and get x equals 41 over 2, and there's the answer, 20.5. Here we have negative 1 over x equals 5/4. Well, to solve for x, first let's move the x up from bottom to top. So we'll take reciprocal of both sides. So I get x over negative 1 equals 4/5. And then we multiply both sides by negative 1. You get x equals negative 4/5, and there you go. Now, rational equations, that's where we have ratios of polynomials. How to solve that, an equation with rational expressions? We find the common denominator and multiply throughout by that and get turned into a polynomial equation, which should be more solvable. Okay, 1 over a equals 1/3 minus 2 over 3a. The common denominator is 3a, 3 and 3a. So multiply by 3a and get 3a over a equals 3a over 3 minus twice 3 over 3a. This cancels to a 3, this cancels to an a, this cancels to a 2. 3 equals a minus 2. Add 2 to both sides. A is 3 plus 2. A is 5, and there that is. Here we have 18 over y plus 1 plus 2 over 5 equals 4. Here the common denominators are 5 and y plus 1, so multiply by that. 18 times 5y plus 1 over y plus 1 plus twice 5y plus 1 over 5 equals 4 times 5y plus 1. For this term, the y plus 1 cancels. leaving a 90. This term, the 5 cancels, leaves a 2y plus 2. 4 times 5 times y plus 1 is 20y plus 20. Here we have a linear equation. Okay, let's subtract 20 from both sides and subtract 2y from both sides. That transposes the 20 to the left and the 2y to the right. 90 plus 2 minus 20 equals 20y minus 20, minus 2y, excuse me. This comes out to, after some work, y equals 4. P minus 1 over 2 plus 1 equals 3 over p. Denominators are 2 and p, so multiply throughout by 2p. P minus 1 over 2 times 2p plus 1 times 2p equals 3 over p times 2p. Here the 2's cancels, here the p's cancel, and you get p squared minus p plus 2p equals 6. After some transposing and combining terms, you get p squared plus p minus 6 equals 0. This factors into p plus 3 times p minus 2 equals 0. And by the 0 factors rule, either this is 0, p plus 3 is 0, so p is negative 3, or p minus 2 is 0, so p equals 2. And these are the solutions. P equals 2 or p equals negative 3. Now, there's a complication. Up here, we had divided by y plus 1. Now, if you plug in 2 or negative 3 in there, there's no problem. But if we had gotten the solution of p of y equals negative 1, then we'd be dividing by 0 here, and that's not allowed. Things go wrong. So for these rational equations, you have to check to see if all the solutions actually make sense, that they don't involve division by 0. When it does, such a root is called extraneous, and you want to throw it out. So for example, here's 3 over r plus 12 over r squared minus 4r equals negative over r minus 4. Okay, first we factor this, r squared minus 4r into r times r minus 4. And we have this equation with denominators r minus 4, and r minus 4. Good. Now I proceed onwards and get a solution, r equals 0. But if you look back here, because we're dividing by r here and here, r can't be 0 because we get it in infinities. Nor can it equal 4 because, again, we'd be getting infinities. So we rule out 0 and 4 at the beginning. And since at the end we wind up with r equals 0, this is an extraneous root. It doesn't work because if you plugged it back in, you get divisions by 0. So you really need to test those roots for a rational equation. All right, here we have x minus 4 over x minus 3 minus x minus 2 over 3 minus x equals x minus 3. Now here we have an x minus 3 and a 3 minus x. They're opposite, so I'm going to rewrite this as an x minus 3 and change this minus sign to a plus sign. X minus 4 over x minus 3 plus x minus 2 over x minus 3 equals x minus 3. Okay, first of all, we have to rule out 3 for x, because then we'd be dividing by 0. But all right, so multiplied throughout by y, x minus 3. It cancels here and multiplies here to get x minus 4 plus x minus 2 equals x minus 3 times x minus 3. Combine terms, multiply out, transpose. 0 equals x squared minus 8x plus 15. This factors into 0 equals x minus 3 times x minus 5. Solutions are 3 and 5. All right. Well, the trouble is we have to check both solutions. Well, and you have to do it against the original equation. For x equals 3, we're getting divisions by 0, which is infinities. So we rule that out. X equals 5. If you work it out, the left side turns out to equal 2. The right side turns out to equal 2. So they match. And so here's our solution. X equals 5 is the valid root. X equals 3 is extraneous. So we proceed with some examples. Solve negative 7w equals 15 minus 2w. We add 2w to both sides to transpose this term to the left. Minus 7w plus 2w equals 15. Minus 5w equals 15. Divide both sides by minus 5. You get w equals 15 over negative 5. So w is negative 3, and there's your solution. You have 4 times y minus a half minus y equals 6 times 5 minus y. Okay, the first thing to do is distribute the 4 and distribute the 6. And so you get 4y minus 4 halves minus y equals 30 minus 6y. We'll move the, the 6y to both sides. This should be a 6, excuse me. P8, page 7, 6y. All right, add that to both sides. Add 2 to both sides, and you get 4y minus y plus 6y equals 30 plus 2. This comes out to 9y equals 32, so y is, that should divide by 9. I don't know why I'm doing this. And you get y equals 32 over 9. Oh dear, something happened. You know what? Something screwy happened. I think maybe we need some numbers that are a bit screwy here, and I am very sorry. This is wrong. I'm gonna have to fix this problem. And I get honked. 32 over 4. Here we have 2x minus 1 over x plus 2 equals y over 5. Multiply by y, both sides by y plus 2. Multiply both sides by 5. The 5 goes to the left, and y plus x plus 2 goes to the right. It's called cross multiplying. You get 5 times 2y minus 1 equals 4 times x plus 2, 2x minus 1. Expand, transpose the 4x to the left and the 5 to the right. 10x minus 4x equals 8 plus 5. 6x equals 13. X equals 13 over 6. All right. Here we have 3 over x plus 4 equals 1 over x plus 6x plus 12 over x squared plus 4x. All right, now this factors into x times x plus 4. So we have to consider 0 and negative 4 to be ruled out from the beginning. We multiply throughout by x plus 4. On the left side, get 3x equals, on the right side, 1 times x plus 4 plus 6x plus 12. All right. Distribute, combine terms, transpose, minus 4x equals 16, x equals 16 over negative 4, but no good. We already ruled out negative 4. So there's the only root we got is extraneous. So this has no valid solutions. Here we have an equation from electrical engineering. When resistances are in parallel, this is the equation that they relate to. The reciprocal of one resistance plus the reciprocal of the other resistance is the reciprocal of the combined resistance. Let's solve for R. Well, first we multiply out the right side, 1R2 plus 1 over R1, R2. So 1 over R equals R2 plus R1 over R1 times R2. Take reciprocal of both sides, and R equals R1, R2 over R2 plus R1. And that concludes that. Okay.